Section 12.5, Part 2, Equations of a Plane. But before we get to equations of plane, I just want to make one more comment about previous video, equations of a line. Remember, these were the parametric equations of a line, which, it shows it goes through the point x0, y0, z0, and it's parallel to the vector ABC, and t goes from negative infinity to infinity. I just want to make sure that we all know that the parametric equations of a line is not unique. In other words, this is not the only correct answer. So the equation which you see here is not one of a kind. Why? Because we can choose a different point or different parameter or different parallel vector, and that definitely changes the equation. For instance, if I have the parametric equation of a line x equals 1 plus 2t, 5 minus 3t, and 11t, if t is 0, one of the points on the line is 1, 5, 0. If t is 1, the other point on the line is 3, 2, 11. And if t is negative 2, the point on the line is negative 3, 11, negative 22. Notice the point changes as you change the parameter. Also, the vector parallel to this line is what? 2, negative 3, 11. But any parallel vector to this vector also does it as far as the equation of the line goes. In other words, I can take half of this, and there goes that one, this vector, which is still parallel to this vector, and it does the job. Or I can just multiply this guy by 4 and get this. In other words, adjusting the vector and the parameter definitely changes the parametric equation of a line, and that changes the equation. Therefore, the equations of a line in a space is not one of a kind. All right. So now, equation of a plane. Notice usually we use parallelogram to indicate a plane in a space. In order to write the equation of a plane, which happens to be the simplest surface in three-dimensional space coordinate system, what you need is a normal vector to the plane, which is denoted by lowercase n, and let's say its component is ABC, and a point on the plane, let's say P0, X0, Y0, Z0, correct? What's the definition of a normal vector to a plane? Normal vector to a plane is a vector which is perpendicular to every vector on the plane. So the minute you draw the normal vector, or determine the normal vector, that normal vector is perpendicular to any vector which you draw on the plane. So what we do, we take a general point like, let's say, P, and construct this vector P0P. And because normal vector is parallel to, is perpendicular to any vector on the plane. So in order for two vectors to be perpendicular, the dot product has to be 0. In other words, what we do, we take A, B, C, which is the normal vector, dotted with this vector, which is x minus x0, y minus y0, z minus z0. Guess what? That's supposed to be equal to 0. However, if you take the dot product, you get A times x minus x0 plus b times y minus y0 plus c times z minus z0 is equal to 0. There you have it. This is called point normal form of the equation of a plane. So this is called point normal form. The point happens to be x0, y0, z0, and the coefficients of these parentheses happens to be the components of the normal vector ABC. So here is the point, correct? So the idea is, can we write the equation of a plane which goes through this point with the normal vector n. So I'm just going to use this formula. Remember the point normal form, a times x minus 0, b times y minus 0, what? C times z minus 0 is equal to 0. So in this case, here is ABC, the component of the normal vector, and here are the components of the point on the plane. So I'm just going to go -1 times x, what? Plus 1, that's minus 1, plus 7 times y plus 1, because that's minus 1, plus c, which is 6 times z minus 2 is equal to 0. Correct? So now if you distribute these coefficients and remove the parentheses, you get -x minus 1 plus 7y plus 7 plus 6z minus 12 is equal to 0. So now this is the same as minus x, 7y plus 6z is equal to, let's say 12, and that's -7, that's plus 1. So that would be like what, 6, is it? So, the equation of the plane is -x plus what? 7y plus 6z is equal to 6. There you have it. Do we all see it? So this is case 1, which happens to be straight from the definition of what? Equation of a plane in space. That's when you know the normal vector to the what? Plane, and you have a point on the plane, you use the point normal form and just make the substitution and you are good to go. Fantastic. So now the idea is what? How do you go about what? This case, in other words, you have a point and you have two non-parallel vectors on the plane. So you got a point and you have what? Two non-parallel vectors on the plane. So how would you go about what? Finding the equation of a plane. So because the normal vector by definition is perpendicular to what? Every vector you draw on the plane, so the normal vector has to be the cross product of v1 and v2. So once you find the components of the normal vector by cross product of these two vectors, let's say you get a, b, c, okay, by finding the cross product of these two vectors, then you use the what? Point normal form, because remember you also given the point, like let's say, -1, 3, 5, and two non-parallel vectors, let's say v1 and v2, then you can finish the problem using this formula and boxing your final answer. In this particular case, so what you have is take the what? Cross product, and then you have the normal vector, because normal vector happens to be what? Perpendicular to both what? Vectors v1 and v2. So that would be like case 2. Alrighty, let's go over, let's say, case 3. What would happen if they give us 3 non-collinear points on the plane? How would you go about finding the equation of a plane if you have what? So-called 3 non-collinear points on the plane. In other words, these points do not lie on what? On the same line. So what you do is what? You form these vectors, P1, P2, and P1, P3. Okay, suppose this guy comes up to, I don't know, let's do P1 and P2. So that's terminal minus initial. So this is like 1, that's like 1. That's like 1 minus 1 is 2. So that's a vector. About P1 and P3, 3 minus 1 is 2, minus 1 minus 2 is -3, 2 minus 1 is 3, correct? So to find a normal vector, remember you have to take what? Cross product of these two vectors, P1, P2 and P1, P3. Why? Because the cross product of two vectors is a vector which is what? Perpendicular to both. And by definition, normal vector is perpendicular to any vector you draw on the plane. So suppose once again you get ABC, and now you use what? Point normal form, like so. Okay, and then finish this problem up. The only question is, which of these points should I select for x0, y0, z0? Answer, any of these points will do the job. Okay, so let's see what the relationship between line and plane is. In other words, there are like 4 cases. I'd like to go over it quickly with you. If they say a line is perpendicular to a plane, that means what? The direction of the line is parallel to what? N. In other words, V should be equal to some scalar multiple of what? N, for the line to be perpendicular to a plane. So for a line to be perpendicular to a plane, the direction of the line has to be parallel to the normal vector to the plane. A line is parallel to what? A plane. A line is parallel to a plane if V is perpendicular to N. In other words, the vector V dot at N has to be equal to 0. A plane parallel to a different plane. That means, when do we say two planes are parallel? If their normals are parallel. What does that mean? That means N1 has to be a scalar multiple of N2. When do we say two planes are perpendicular to each other? When what? The normals are perpendicular. What does that mean? That means N1 dotted with N2 has to be equal to 0, the number. Fantastic. So moving along here. So let me find the next page, which is this guy. So how would you go about finding the equation of what? A plane containing the point, this guy, -2, 8, 10, but it's perpendicular to what? To the line with parametric equation 1 plus t, 2t, 4 minus 3t. Don't forget t goes from what? Negative infinity to infinity. Remember what we just said a while ago, that what? A line is perpendicular to a plane if what? The vector parallel to the line is what? Is scalar multiple of what? Normal vector. So what does that mean? That means the vector which is parallel to what? What? To this line is 1, 2, -3. Because what? If the line is going to be perpendicular to the plane, then the direction of the line has to be parallel to the normal. So I can pretend this is normal vector. Or you could also take any scalar multiple of this and claim that as your normal vector. Once you have that and you got your point, which is like x0, y0, z0, notice we always, no matter what the situation is, we always come back to this point normal form. In this case, A, B, C happens to be 1, 2, -3, and x0, y0, z0 is -2, 8, and 10. So therefore, this would be like 1 times x plus 2, what? 2 times y minus 8, and -3 times what? Z minus 10 equals 0. Then you clean this up, you get x plus 2y minus 3z is equal to -2 plus 16, what? Minus 30. So that will be x plus 2y minus 3z, that's 14 minus 30, which is negative what? 16, is it? Is that right? Negative 16. So that would be like what? negative 16. So the final answer would be like what? X plus 2y minus 3z equals negative 16. Question: how did you know the normal goes upwards, not downwards? Well, it really doesn't matter because any scalar multiple of this will do the job. In other words, if you had the negative of this, which that means your normal is pointing this way, opposite direction, at the end, when you multiply both sides by negative, you still get what? Same answer. So don't panic. The next example is find the equation of a plane that contains the line, this guy, and it's parallel to a different plane. So what's happening is the following. So these two planes are parallel. When do we say two planes are parallel to each other? So two parallel planes, that implies N1 is parallel to what? N2. That means their normals have to be parallel to each other, correct? So how do you determine the normal vector to this plane? Well, remember, if you kind of simplify what this so-called point normal form and remove the parentheses, you will end up with the general form ax plus by plus cz is equal to d, and d happens to be what? Ax0 plus what? by0 plus c0, which they are all constants. So d contains all of those constants. So this is alternative form of this point slope form. So what I'm saying is, notice the coefficients of what? X and Y and Z happens to be the components of what? Of the normal vector A, B, C, normal vector N. So what I'm saying is, if they give you the equation of the what? Plane in a standard form, like so, excuse me, you can by inspection, find the normal vector to the plane, which happens to be the coefficients of X and Y and Z. So in this case is 2, 4, 8. Okay. So now, the equation of a plane that contains the line. So what you do, you kind of what? Select a point on the line, correct? So how do I select a point on the line? I don't know, choose any value of t which your heart desires, such as t is equal to 0, and get 3, 0, 8, a point on the line. Suppose now we select what? A point on the plane pxy, correct? Pxyz, and now form this what? Vector. So you would get what? P0p is equal to x minus what? 3, and then y, excuse me guys, minus 0, terminal minus initial, and z minus 8. Keep in mind, normal vector is what? So if this is the normal vector, the components of the normal vector for plane number 2, you can also use that or any scalar multiple of that for the components of normal vector for plane B, A. So this is plane number 1, let's say. This is plane number 2. Okay, so so by definition of the normal vector to any plane is a vector which is perpendicular to any vector you draw in that plane. So what that means, N1 dotted with P0P should be equal to 0, correct? So remember, this is your N, what, 1. That was N2, but N1 is scalar multiple of N2. So pretend I multiplied this guy by 1. Okay, so I get 2, 4, what? 8 dotted with x minus 3, y minus 0, terminal minus initial, and z minus 8, and this supposed to end up with 0. So if we do the cross multiplication, you get 2 times x minus 3 plus 4 times y plus 8 times z minus 8 is equal to 0. Then you can clean this up and kind of sort of write it as what? 2x plus 4y plus 8z is equal to what? 70. And that would be in the standard form. And that's the final answer for this problem. Keep in mind, in order to have two parallel planes, their normals have to be parallel. What does that mean? The normal of one plane has to be scalar multiple of the other plane. Otherwise, they will not be parallel, correct? Okay, so before we get into the next topic, let me show you graphs of a variety of planes. If z is equal to constant, so that's a plane which is perpendicular to what? It's like 5 units above the what? Floor, and it's parallel to the floor. So it's a plane. Notice we show the plane by a parallelogram. So this is a plane which is perpendicular to the z-axis and it's parallel to the floor, 5 units above the floor. So the graph is a plane. Why is that? Because when you say z is equal to 5, what you're saying is 0x plus 0y plus 1z is equal to 5. Remember, any linear equation in terms of x, y, z happens to be the graph of a plane. It just so happens the coefficient of x and y is 0, but that doesn't mean x or y is 0. That just means x and y can be anywhere between, can go anywhere between negative infinity to infinity. So this guy extends this way and this way, but it just stays at what? 5 for z fixed. Y equal 3, so it's a perpendicular to the y-axis, but it's parallel to what? XZ plane, so it's kind of like sidewall. X equals 1 is the front, right? It's parallel to the what? YZ plane, is that right? But it crosses the what? X-axis at 1. 2x plus y is equal to 4. Remember, this is the same as 2x plus y plus 0z is equal to 4. So the way you do this, on xy plane, that means on the floor, the graph is a line which hits the x-axis at 2 and y-axis at 4. How do you know that? Set x equal to 0, y is 4. Now set y equal to 0, x is 2. So this is the graph on the floor, which happens to be a line. However, z is missing, but that doesn't mean z is 0. That means z goes from negative infinity to infinity. So we need to kind of stretch this along the what? Z-axis. So what's the graph? The graph is still a plane, okay? And it's a vertical plane that lies over the line, what? 2x plus 4 on the xy plane. So it just goes up and down forever. Y equals x is a line on the xy plane, which makes a 45 degrees angle with either x or y. So here's the graph on the floor, but keep in mind, once again, what? As z is missing, so that means z is goes from negative infinity to infinity. So you've got to stretch this along the z-axis, and that's called extension. Z equals x, that's a line on the what? XZ plane. But notice y is missing, so y goes from negative infinity to infinity. So this line is what? Z is equal to x on XZ plane. But y is missing, so that means y goes from negative infinity to infinity. So the graph is still a plane. If you have x plus y plus z is equal to 0, find the intercept, x and y and z intercepts and connect the dots. For instance, to find the x-intercept, what do? I set y and z is equal to 0, I get x equals 1. Similarly, if I set x and z equal to 0, I get 1 for y, so this is 1, 0, 0. This guy is 0, 1, 0, and this guy is what? 0, 0, 1. Connect the dots, lo and behold, you get a plane, okay, which crosses the x and y and z axis at 1. All right, so now let's talk about distance problems, correct? So how do you go about finding distances? So the first problem happens to be what? The distance between a point and a plane. So here is the point, let's say point P, which is given to us. So this is given, and this equation of the plane is given. I'd like to find the shortest distance between this point and this plane. How would I do that? Well, pick a point on the plane. How do I pick a point on the plane? Well, pick values of x and y and z, which satisfies the equation of the plane. Okay, how? Well, what I did, I set y and z equal to 0, so x came up to 5/3. In other words, 5/3, 0, 0 should satisfy this equation. Is this the only point on the plane? No. This is just the point which I selected. So I'm going to go 5/3, 0, 0, correct? So now form this vector QP, okay? What is the relationship between normal vector and this vector, okay? Well, there is no relationship because this vector doesn't lie on the plane. Otherwise, I would have said take the dot product and set it equal to 0. I'm trying to find the distance. Remember, the distance between the point and the plane is the shortest distance. As a matter of fact, if you drop a line on the z-axis, this is the distance we are talking about. You see it. But the normal vector forms an angle of theta with this vector, which we constructed. Okay, how did we construct this? We selected a point on the plane by, choosing set of ordered triples such that it satisfies the equation. Okay, and then we form this vector. In other words, we have QP. Remember the way you form a vector by knowing the initial and the terminal point of the vector, you go terminal minus initial. So this would be negative 5/3, 1, and 5, correct? So how do I find D? Well, looks to me this is a right triangle, correct? So looks to me also D is kind of like a scalar component or the shadow of what? Of QP onto the normal vector. So this would be scalar, what? Projection of what? QP onto N. So how do I do this? Well, remember the formula was what? Absolute value of what? QP dotted with N divided by magnitude of N. Well, how did that come about? Well, let's see now. D is equal to what? Magnitude of QP times cosine of theta. So all you have to do is give a denominator of 1 and multiply top and bottom by magnitude of what? N. Okay. But these three items, the product of those items happens to be exactly the definition of what? QP dotted with N over magnitude of N, right? Remember the dot product, the alternative formula was what? The dot product of A and B is magnitude of A, magnitude of B, times cosine of the angle between A and B. And remember, theta goes between 0 and pi. Because this is distance and the dot product may come up what? Negative, so we use absolute value bars. Yes, so that's basically how you find it. All right, so make the long story short, I got this. N is right here by inspection. I can tell N is what? 3, 6, -2. Remember the way we find the components of the normal vector, we take the coefficients of x and y and z in the equation of a plane. Do you see it? Take the dot product and take its absolute value. Believe it or not, I came up with -9, and then magnitude of what? N, I came up with the square root of 9 and 16 and 4. But remember, this is distance. Make sure you take the absolute value of the dot product. So it comes up to -9, but absolute value of -9 is 9. And I believe this guy is a square root of what? 49, which is 9/7. Notice the distance always, rain or shine, has to come up as a positive answer. Okay, so what about the distance between two parallel lines? Remember, we're talking about distance problems. So case one was what? Distance between a point and a plane. Now the next question is, what if I got two parallel planes? How would I find the distance between these two parallel planes? To begin with, check and see what the planes are. The planes are parallel. How would I check? Well, the normal vector for the first plane is 1, 1, 1, because that will be the coefficients of what? X and Y and Z in the standard form of equation of a plane. And the components of the normal vector to plane number 2 is also 1, 1, 1. So N1 is 1 times N2. In other words, it's a scalar multiple of N2. So N1 is parallel to N2. That in turn tells us what? Plane 1 is parallel to what? Plane 2. So we already checked and notice that the planes are parallel. So how would you find the distance? Well, pick a point on this plane, and the point I selected, then again, I set X and Y and Z equal to 0. I came up with -1, 0, 0. Just pick any point which satisfies this equation. One of many, many points you can select is -1, 0, 0. Now select a point on this plane which satisfies this equation. And I chose 1, 0, 0. 1 plus 0 plus 0 adds up to 1. So you guessed it, you know what I'm going to do. I'm going to make this connection, come up with what? Vector QP, remember terminal minus initial, that's 2, 0, 0. Correct? And then you know what we're going to do. Here is the what? Shortest distance. Here is theta. You know what we're going to do. What is the formula? It's scalar projection of QP onto, let's say, N2. Correct? Okay, so this would be what? Absolute value of QP dotted with N2 over magnitude of N2. For the same similar reason which we did previous example. In this case, you would end up with absolute value of 2 over square root of 3, which is 2 over square root of 3, and that would be the end of that problem. So that's how you find the distance between what? Two parallel lines. Okay, the last topic of this chapter, this section, is how do you find the angle between two intersecting planes? Two planes intersect each other in a line, and they form these angles. Okay, so it's either what? Theta or 180 minus theta. Depending on the direction of N1 and N2, you either get an acute angle or obtuse. Usually, or by definition, we are interested in acute angle. Okay. So this is the one we are interested. We are not interested in obtuse. That's by definition. So the angle between two intersecting planes is the acute angle. That means theta has to be between 0 and 90 between their normal vectors, meaning N1 and N2. Okay, so all I have to do in order to find the angle between two planes is find the acute angle, which is between 0 and 90, between the normal vectors of two planes. Remember the normal vector for this plane. Remember, those are the components of the normal are coefficients of x and y and z. So this is 2, -4, 4. And the normal vector for this plane is what? 6, 2, -3. So how do you go about finding the angle between two vectors? In this case, the vectors happens to be the normal vectors to the plane. Remember the formula, N1 dotted with N2 equals magnitude of N1 times magnitude of N2 times the cosine of the angle between what? N1 and N2. That's the alternative definition of what? Dot product of two vectors. So what you do is you take 2, -4, 4, dotted with 6, 2, -3, is that right? And then magnitude of N1, which is what? 4 plus 16 plus 16 times magnitude of N2, which is 36 plus 4 plus 9 times cosine of theta. Do you see it? So now that we got so-called what? The formula going, so all you have to do is what? Perform these operations and see what theta is. So let's say this is what? 12 minus 8 minus 12, is that right? Equals the square root of, what's that? 20, that's 36. What's that? 49 cosine of theta. Is that right? Did I do this right? So that would be like what? 2, -4, 4, 6, 2, -3. That's 12, -8, and -12. Correct. So these guys cancel. So give you a -8. What? This is 6 times 7 cosine of theta. And cosine of theta is equal to what? -8 over 42. So theta happens to be now what? Is cosine inverse of -8 over 42. So that's going to give you an acute angle, right? I mean obtuse, but keep in mind the final answer has to come up as what? As acute. Make sure you select the acute angle. So, you know, whatever this is subtracted off of 180, so you can come up with an acute angle, correct? Because that's basically how we find what? The angle between two what? Planes. As a matter of fact, when you do this, you get theta is equal to 100.98 degrees, but that ain't it. So you cannot have what? Acute angles. So take 180, subtract 100.98 degrees. So the final answer is roughly equal to what? 79 degrees, roughly. So remember, the answer has to come up between 0 and what? 90 degrees. Couple of comments before we hit the last portion of this so-called section. two lines intersect each other at a point, okay, if they do intersect, and two planes intersect each other at what? A line, if they do intersect. Thank you.